Hello, my presentation is about quality of service and traffic shaping. Quality of service is when some applications demand higher performance close to perfect and best under the circumstances. One solution is over provisioning, building a network that enough capacity to overcome any possible traffic that will be thrown at it, and the network will carry application traffic with no significant loss, low latency packets. The only problem about the system is that it is expensive. When we're looking at the quality of service, four issues that need to be addressed are what applications need from the network, how to regulate the traffic that enters the network, how to reserve resources at routers to guarantee performance, and whether the network can safely accept more traffic. No technique can handle all of the issues by itself, so a variety of techniques are developed to be used at the network and transport layer. Application requirements. The need of each flow can be characterized by four primary parameters: bandwidth, delay, jitter, and loss. These four parameters determine the quality of service the flow requires. The network requirements are less demanding than application requirements in the cases that application can improve on the service provided by the networks. Networks do not need to be lossless. Some amount of loss can be repaired with retransmissions, and some amount of jittering can be smoothed by buffering. There is nothing that the application can do if the network's not providing enough bandwidth and there's too much delay, because it's based on and depends on the network, because since that's how it is. Applications different bandwidth requirements, like email, audio, and remote login do not need much network bandwidth requirements because it's not live or it's not big files. However, videos and file sharing needs a lot more than the other ones since it's bigger files and it's more data. Emails, audio sharing, file sharing are not sensitive to delay. A few seconds of delay will do no harm. However, interactive applications are more delay sensitive. Real-time applications like phone have strict delay requirements. Videos or audio files are not as important as phones. Because phones are in real time, you have to be talking to the person and you have to get an answer as soon as possible. If you have delay, that communication will be delayed, and this can cause many problems in the area. For this, we can do traffic shaping, and traffic shaping is the technique for regulating the average rate of flow of data that enters the network. Before the quality of service is guaranteed, we need to know the guarantee of the amount of traffic so that the quality of service can be made for that. Traffic in data networks is bursty. It arrives at a non-uniform rate as the traffic rates vary. Users interact with applications and computers switch between tasks. Burst of traffic is harder to handle than constant rate traffic. The goal is to transmit a wide variety of traffic that suits the needs, but have simple way of describing the traffic patterns to the network. SLA, Service Level Agreement, is an agreement that is about if you tell how your traffic is going to be and you ask if you can handle it. As long as the customer holds their promise, which means sends packets according to the agreed upon contract, the provider promises to deliver them all in a timely fashion. Traffic shaping reduces congestion and helps with the network to live up to its promise. And with this, the provider monitors and maybe drops and changes the priority of bigger packets. One technique for traffic shaping is leaky and token buckets. They are a different algorithm that works in a different way, but it is used for the same purpose. This bucket can be used to shape or track the packets entering the network. Each host is connected to the network by an interface with a leaky bucket. If a packet arrives when the bucket is full, the packet either needs to wait or it will be discarded. Like in the picture, this is literally like a bucket, which is the first in comes out first, and it fills up. It depends on what the situation is. Leaky and token buckets limit the long-term rate of a flow but allow short-term bursts up to a maximum regulated length to pass through unaltered and without suffering any artificial delays. Large bursts will be smoothed by a leaky bucket traffic shaper to reduce congestion in the network. If traffic is sent in a different pattern, some of it will be dropped in the network because it does not fit into the buffers at routers, which kind of means it does not fit into the bucket. To avoid this packet loss, we can shape the traffic at the host with a token bucket. One way to get smoother traffic is to insert a second token bucket after the first one. The rate of the second bucket should be much higher than the first one. The first bucket characterizes the traffic, fixing its average rate but allowing some bursts. The second bucket reduces the peak rate at which the bursts are sent into the network. And my question for the class was, what is traffic shaping?